All right, guys, I think we're gonna go ahead and get started. Maybe some more people will trickle in. So if I remember correctly, we were kind of going over, I wonder if I still have my old C++. Anyway, we'll make a new one. We were going over functions. I want to hit return statements before we move on to objects, just because it's a really common thing you'll see. So, and if you guys have your file from last time, you can go ahead and use that. I'm just making a new one because I'm not quite sure what I did with my old one. If you guys don't remember, you go ahead and just type something random in here, and you can open your file, save as. And then you'll just have to specify it as a C++ file. I'm going to go ahead and new class.cpp, save, and now we get syntax highlighting. Okay, so I'll go ahead and set up my main again. Okay. And I'm gonna go ahead and declare a function. So just like last time, remember the syntax for declaring functions is first the return type, the name, and then of course you need parentheses for arguments. So with the return type, this is where it's actually gonna come into play. So last time, I don't think we did anything besides void. So when you make a void function, that means that it's not giving off any information. And what that actually means is if I were going to come in here and let's say, let's say that this, I have an int, okay, and I want this int to be set to whatever my function gives off. Right now, if I try to do int a equals my function, I tried to run that, it's going to get mad at me. So it's highlighting this. And it's not allowing me to do this because currently the return type is void, okay? Well, two reasons. Return type is void, and then that'll come into play with the return keyword. So if I want to be able to do something like this, what I have to do is I have to come here and actually change the data type. So because I'm trying to assign it to an int, I'm going to make this an int function. Okay, so now this will actually allow me to do this kind of a statement. And in order to specify what your function is actually going to give off, you have to use the return keyword. So literally all this function is going to do is it's just going to return, return a 5, okay? And actually that reminds me, I forgot to do return 0 up here, and I'll explain that later, but what's important right now is just to notice that this is returning the number 5. So now if I go ahead and run it, and I didn't make a function prototype yet again because I'm a Java programmer and don't remember that. Why on earth is this not working? That's because it is. Thanks, Leif. All right, fantastic. All right, actually built and compiled. So just to prove to you guys that it actually did return a 5, we're just going to do a cout a. And I didn't include this, and I'll explain this later because that's actually has to do with classes that we'll get to. But now you can see that we did in fact return a 5. So normally you wouldn't just return a constant. You'd probably, come in here, do some fancy logic, and return something at the end. But that's how you actually make a function return information. So you can have it do something, and instead of just execute and not actually get anything from it, you can return something. So, and you can still run a function like this without assigning it to anything. So if I was to comment out this and just run my function, it's still gonna run. If I actually comment out everything that I declared. It's still going to run. We just don't have any. It would still execute everything that's inside. It just wouldn't actually use the return. It would just spit it out into empty space and nothing would happen. But you can still execute it. So, all right. Trying to think if there's anything else with functions that I haven't gone over yet that are kind of important. Probably should actually pull up my notes. That might be a good idea. Let's see here. Do I have it here? I do. Fantastic. Functions. Nope, looks good. All right. So let's move on to the harder stuff. Classes, more specifically objects. The whole reason that C++ was effectively created was to include something called object-oriented programming. In essence, it's just a much better way to program things for the world that we live in. We live in a world full of objects, things, and it's a much better way to think about it when you're programming as well. So when you make an object, what you do is you declare something that's called a class. Class is just a fancy way of saying it's basically C++'s word for object, class. And when you make a class, you basically split it up into two different files. You split it up into your header file and then your actual C++ file for the class. Because we have multiple files when we do this, we can't just use the standard C++ compiler, because the C++ compiler doesn't just go and find multiple files. So what we have to do is we have to actually create a project in code blocks. When you're doing the actual robotic stuff, you won't be using code blocks, just use something called catkin. But for this, just for learning, it's super simple. We're going to use the code blocks version. So what I'm going to do is I guess I can leave that for now. We're going to come over here and we're going to say file, new, project. And this would be a good thing to follow along with and to have on hand if you have it working. Even if you don't have your compiler working, still go ahead and type this because it'd be good to have on hand and be able to look back at. But we're going to go file, new project. We have to come over here and we have to select the one that's a console application, and that just means bare bones minimal project. So we're going to click on that, and it brings up this nice little setup wizard, and make sure that you have C++ selected. And I'm going to call this first class. And I'm selecting where it saves to. I think right now, yeah, mine's saving it to the programming class. So I'm going to hit OK. Go ahead and hit next. You can leave all this the same. Don't mess with any of that. Go ahead and click finish. And what it's going to do is it's going to generate the project. Now, I guess it's keeping this in my editor, so I'm going to get rid of it, just so it's not confusing. You'll see over here, we have this file tree. And inside of the first class project, right now, it only has one folder called sources, and it automatically generated a main.cpp. And you see that it just given us the bare bones minimal hello world kind of a thing. So if I run this, it'll just run that, and we get hello world. So we're not going to use this. We are going to leave the main.cpp. I'm just going to get rid of this cout hello world. Okay, so now actually, first of all, can I get somebody give me a thing, anything, not like give it to me, give me an idea, like a thing, an example of a thing. Don't think too hard. What'd you say? A speaker. You're talking like, where are they at? You mean like, yeah, speaker. Okay, we can make a speaker class if that makes sense to you guys. So what I'm going to do is I'm going to come over here to my sources. Well, actually, no, I'll do that. File new, new empty file. And it'll ask you if you want to save it to the project. We're going to say yes. So this is going to be the file name. Since we're making a speaker class, a class for speakers, audio speakers, I'm going to make speaker. I'm going to make this a .h file, and that means the header file. And if you just click save, it's going to automatically put it and hit OK. It's automatically going to make a new directory called headers, and it's going to put speaker.h in here. So now we have speaker.h. And another thing, next thing we're going to do is we're going to make another new file. Do the same kind of a thing, and we're just, except for we're going to name this one speaker.cpp. Save, OK. And it's going to add this to our source folder because it's a C++ file. First thing we're going to mess with, though, is the speaker.h file. And just like when you make functions in C++, you have to create a prototype. And that's exactly what the H file is for, the header file. You're basically creating a prototype for all the functions inside of your class. And it's also where you're going to declare all the variables and things for your class. So when you're making a class, what you want to do is you want to take a step back and you want to say, okay, what is everything that makes this speaker a speaker? So first thing that comes to my head is, of course, like volume. Okay, so what we can do is we can put, let's say an int, a number in int. We can put an int inside of our class. Okay, and that int represents the volume for the speaker class. Okay. So let's go ahead and do that. I'm going to show you guys just the basic shell when you're making a class, and then we're going to add this volume variable. So the keyword is, guess what? Class. If it'll let me type. Class. And then the class name. And when you're making a class name, it's good syntax, or just good practice to make it a capital, upper camel case. So speaker. And then you're going to use your open and close curly brackets. And you'll notice that it actually auto-completed. It put a semicolon at the end. I mean, when you're making functions, you don't put a semicolon, but because a class is, it's basically a declaration. So you need this semicolon because it holds not just function information, but also like variable information. There's a lot of stuff, and it's just the syntax. You put a semicolon on the end of it. Okay, so now your class is split up into two different sections, your public section and your private section. I will explain those later, but for now, we'll go ahead and add them. And you put public first. You don't have to, but that's just the way you should do it. So public, and then you say private. And both those keywords are ended with a colon, not a semicolon, a colon. Okay, so let's go ahead and let's add that volume variable. And I'm going to add it to the public section right now. And I'm going to it's just literally the same to add anything you want for variables. So just int volume, yeah, that's literally all you do, int volume. We're not going to set it equal to anything. I don't know if in C++ you could, but you shouldn't. So int volume. So now this speaker class has a volume. Let's go ahead and let's give it a function though. So since we have a volume, we should probably make a way to set the volume. So let's go ahead and make a function. I'm going to make it a void function. Set volume. Now you don't need to make a prototype up above this because this is the prototype. Actually, I need to add an argument so we can actually pass it a volume. So that's going to be an int. I'm going to name it just vol, int vol. So yeah, this is our prototype. And that's the whole point of the header file. And now, oh, why am I in the C++? Okay, I was editing in the C++. Let's actually put it in the header file. Okay, fun. Okay, speaker.h. Now it's actually in the H file. Can't believe you guys didn't say anything. If you see me doing stupid stuff like that, you should say something. But yeah, so we have the H file. So now let's come into here and let's actually declare or define this function here. And you do that in the C++ file. Now, in order to actually be able to declare or define this function, we need to actually include the H file. And that's the same syntax as if you're including any other library. Just pound include And instead of using those guys though, the open and closed or less than greater than, you use quotes. And if I start typing speaker, you should see it auto completes it, speaker.h. And so now we can actually go and define those functions. So speaker.h, yep, okay. So when you're defining these functions, the syntax is there's one little piece you need to add. We need to make sure it's the same data type, of course. So it's a void. So we're going to come over here and we're just going to say void. But now this is where the another piece comes into play. What we need to specify the namespace for this function, because we're declaring it, we're defining it outside of the H file. We need to tell it what class this function belongs to. And the way you do that is, let's see here, speaker, yep. So speaker is a class, so you put speaker, so void speaker, and then you put colon. You notice that it's auto-completing to set volume, so I can just hit that. And what it's saying is, set volume belongs to speaker. And now we can actually define it. So let's just say, oh yeah, we have an argument, don't we? In vol. Okay. So now let's actually set that volume. So what we can do is, yeah, in volume. Volume equals, and let's set it equal to vol. Volume equals vol. Okay. So now what we've done is we've come in here and we've taken this and we've actually defined it. And the reason that they split it up into these two files is because they make it makes it a lot neater to read and write. Because you can go in here and you can see what is everything that belongs to this class, okay? And that's all you're seeing. You're not getting a bunch of other information. And if you actually want to go and you want to see what set volume is, you can come into your speaker CPP and you can look at everything. Okay. So now we need to get on to another really a crucial idea for classes and object-oriented programming. When I make this class, what I'm effectively making is what you can think of as kind of like a template. I'm basically making a way to make more of one thing. So when you're making the class, you want to be able to make more of it. You know, you don't just want to make one speaker in your world. You want to be able to make as many speakers as you want, but with like different volumes. Obviously, you don't want them all to be set to the same volume. That would be ridiculous. And then that's what we call creating an instance. Okay. So what I can do is I can take the speaker class. Okay. And I can make one instance, and I can set its volume to 15%, okay? And then I can make another instance, and I can make its volume 75%, okay? Now, these two instances are operating just completely independent of each other. And then that's how object-oriented programming is very useful, is you can make multiple instances of it. So let's go ahead and make the instance of the class. We're gonna come over here to our main CPP. And just like we include the H file, we have to do it again here. So pound include, same syntax, speaker.h. Okay, and so now the syntax for creating an instance of a class is you're gonna first put the class name. So it's basically like the data type, but speaker. And then you're gonna give it a name, same syntax, speaker, and we're gonna call this just speaker A, semicolon. That's all you have to do, speaker A, semicolon. And so now if I want to access the set volume, you don't use a namespace or anything like that. It's just a simple dot. I'm trying to think if there's any, I don't think there's any, yeah, since none of you are in 150, but anyway, so you don't really have any examples of that yet. But yeah, so use just a simple period. So we're gonna do a dot set volume. Oop, I thought it would autocomplete. Set volume. So what I'm doing is I'm setting the volume of just this instance A. And I'm going to set it to 5. And I have IO stream. So what I can do is I can also just see out A dot volume. So yeah, just the same way that you access the function is also the same way you access the variables. So when I come in here and it's going through this and it's reading this, it hits this point and it says a.setVolume, and what it does is it goes to this version of set volume and then actually sets the volume to 5. And now this version, this volume here is now 5, but only for this A. Let's go ahead and build and run though. Figure out if I did everything right. Oh, I did. Fantastic. So yeah, we got a 5. But now just to show you guys that it's only affected this instance, I'm going to create another instance of the class. Let's make speaker B. And now if I come in here and I do B dot set volume, and I'm going to set it to 76. Now if I see out B dot volume, oops. If I see out B dot volume, and I should probably end L so I don't get it like on the same line, build and run. Okay, so we have our 2 different numbers. So only the instance, so the A instance has a 5 for its volume. The B instance has a 76 for its volume. And I can create as many instances as I want, and I can change all their variables, and they'll all have different variables. To put this into a much more applicable example, when you're actually go to do your programming for robotics, you'll be creating instances of motor controllers. And you want to be able to set all the motor controller speeds and like outputs to different things. So that's a really good example of where object-oriented programming is pretty much critical. Because if you're trying to do that in like a C program, I don't even think you can really do that in a C program. You'd have to like make different files for all your motor controllers, and they'd all be like the exact same thing. And so that's just how programming used to be. So then they came along and they were like, okay, this is really hard and doesn't make any sense. And then they came along and they decided that this object-oriented programming was going to be a much better way to do programming from here on out. And of course, they still use like the C style where it just executes from top to bottom, and no objects or anything like that. That still has a place, but this object-oriented programming is really cool, and it allows us to do a lot of stuff a lot more efficiently. Okay, all right. So now let's go ahead and let's see here. Okay, so I mentioned namespaces when I defined this guy, speaker namespace. I remember when we first made our first main program, I told you to add this using namespace standard. And I told you I'd explain it later. Well, now it's later. So if I were to remove this, oh, did I not close it? I didn't close it. If I remove that and I try to build and run, it's gonna get mad at cout. Now that's because cout is a part of the standard library, more specifically the standard class. So without this, what I need to do in order to actually use cout is I would need to do the same kind of a thing, standard and double colon, to actually be able to access the cout function. And now if I run it, it's actually going to run. Why didn't you run? Oh, same thing. Look, endl. Complained again because I didn't do it to endl. Yeah, these are all actually functions. Cout is a function, endl is a function. So in order to actually be able to use it, you need to specify the namespace. And one way you can do that for your entire program, because that's really annoying to have to write standard : : in front of everything, is you can use that using namespace. And the only time that you need to do the using namespace is if you're defining the functions for a class. That's one of the times. The other time is if you're using a function that doesn't have an instance. So you'll notice that we didn't have to use it on set volume, but that's because A is an instance, and it knows what class it's a part of because we defined it up here. So that's something you'll run into a lot of when you're actually going to do the robotics programming. Yeah, you'll have to put a bunch of namespaces and stuff. You'll have to add a bunch of using namespaces to actually be able to use all the functions that you want to use and not have it complain at you. Okay. So next thing let's go ahead and explain this public and private. And this again plays into that idea of scope. So you remember when I was explaining functions, and I created a variable inside of a function that was down here, and then I tried to access it up here. It's that same kind of idea, but what we can do with a class is we can actually tell it what variables we want the class instance to just be able to access. So right now you'll notice that the volume is part of it's public. And that means that I can do stuff like this. I can just see out the volume just by accessing it. But if I were to come in here and move this to the private and declare and make it private, now if I try to run, it's not gonna. Yeah, it's just referencing it here to show me that it's private. But what it's complaining about is, yeah, in function main. It's complaining about this because this is no longer public, which means that I can't access it with an instance. And the reason that this is here is because if you're creating, a lot of times when people create classes and then other people are going to use that class. Well, the people that are using that class don't necessarily need to know everything about like how the class works. And one way that you can basically make it so that they can't mess up the class when they're trying to use it is you can declare things private and public. So like set volume, for example, in reality, if you're going to make a set volume function, it's not going to be as simple as like volume equals. There's going to be a bunch of other like fancy stuff happening. It's probably going to be like a function 50 lines long with a bunch of variables. But you don't want them being able to just go in and change those types of variables because they don't need to. You already did everything for them. So it's a lot better if they can just say, oh, set volume 10, and it just happens for them. So with this set volume, I've actually gone a little bit ahead and showed you guys how it's like good practice to deal with variables in classes. Very rarely do you actually make a variable in a class public. What you do is you make it private, and then you use something things called setters and getters, and they are exactly what they sound like. You make functions to set the value, and you make other functions to get the value, and then you make other functions to change the value, but you never actually give them access to the value. And that makes it, in a way, it makes it easier for them to use your class because they don't have to like wonder, oh, what's this variable doing? And you can do the same thing with functions as well. So like, let's say set volume is using other functions for like, I don't know. I'm not really a speaker person. I don't really know what the internals of a speaker are. Like you're gonna have like a button. So like get button might be a class, but you don't need them to have access to get button. So what you do is you'd make get button private, and then like set volume would call the get button function. So you can create kind of like these layers of things that you want them to access and things that you don't want them to have access to. Okay, so does that kind of make sense? Do you have any questions at this point? Okay, I should have left this up because now I'm wondering what I had next. Yeah, that's actually the end of my notes. So, okay, we're just going to use this main.cpp, and I'm going to go over a few more just basic programming things. One in particular that I want to go over is something called an array. Okay, and what an array is, we're shifting gears here. Now this has nothing to do with classes. This has everything to do actually with your data types. I'm gonna go ahead and I'm just gonna get rid of all this, just so it's not in the way. I'm gonna leave the include, just in case I want to use it later for whatever reason. But what an array is it's basically, it's a very nice way to be able to group numbers together. So like, let's say you were making a program, you're making a program to, or a part of a program that like, so like for a video game, and you wanna be able to hold everyone's score, okay? You don't wanna have to make 50 different variables for someone's score. No, what you wanna be able to like group it all together. And a nice way to do that is to use what's called an array. So basically what an array is in memory, I wish I could write on this and have people see it. I can't though. Well, I'll do it for you guys and everyone else can just listen. But in memory, when you make a data type, what it does is it goes into memory and it just claims basically a spot for it. So this is going to be we were talking about volume. So this is going to be my int volume. And this is a space that the computer uses to hold the information for volume, okay? What an array is, so I'm going to make an array for the video game scores again. So this is my array scores. Instead of having one slot, what you have is a whole long line of slots, okay? And it just breaks it up into however many slots you want. And what you can do is in the first one, this is one person's score. They're not doing well. They have a 0. This next person has a 500. Just gets stored in the next slot. And this just extends as far down as your array exists. So let's actually go ahead and look at how you define one of these things. Okay, good idea. Okay. I can move that down. Yep, fantastic. So now you guys can see the madness I wrote on the board, kind of. Anyway, so when you're defining an array, it's very similar to defining just a regular variable. But we're going to finally get to be we've used basically parentheses, we've used the curly braces. It's auto-completing on me now. Now we're going to use the square braces. The square braces are basically reserved entirely for arrays. So just like a variable, you're going to first declare a data type, so int, and let's use that video game scores. I'm going to put scores. And then after that, you're going to put these two square brackets, semicolon. Now, when you're defining it, what goes inside the square brackets is the size of the array. So in this video game, we're going to have 5 people playing. 5. So if we go back over here, I actually have one too few. So I'm going to make this one too. Oh, no, I had enough. I had a small one over there. Anyway, so this is our scores array. And It's not really an array, it's held as an int. So this is my int scores. Now I've declared it 5 slots. Now with arrays though, they're not numbered 1 through 5. You actually start at 0, which can be like, it's one of those things you're gonna forget when you're first using it. But so these are actually not 1 through 5. This is 0, 1, 2, 3, and 4. And one thing that's really important to remember about that is because there's no 5, if you try to, like, let's say, so you're going along, you're changing everyone's scores. If you try to come over here and change number 5, what's going to happen is your program's going to crash because there is a memory slot here. It's just not part of your array. So it's going to come over here. It's going to try to access this, and your computer's going to crash because your program's going to crash because your computer's like, you don't actually have access to this space right here. So that's something it's really important to keep in mind, how big your array actually is. So, because some languages will actually, it won't crash the program if you go outside of your array. C++ will. It's like, nope, I'm not smart enough for this. I'm just going to shut it down before you do any more damage. So stay inside your bounds. That's what it's called, bounds checking, to see if you've actually gone outside of your array. So if we want to go ahead and we want to access, this person just had a score update. They've actually scored, so they're no longer at 0. Let's change their score. So what we can do is we can come in here and we're going to say scores. And we're going to use our square brackets again. Now what we're doing here, we're not defining the size. We're gonna say which element, being like which memory space, do we want to change. And we're going to change the very first one, which is 0. So element 0. From now on, I'm not going to say the first one. I'm going to say element 0, try and ingrain it into you guys' head. Element 0 equals, and they now have 23 points. So if I run this, make sure that I actually told you guys everything correctly, and I did. So now what it's done is it's come in here. It's said you have your array of ints. Bada book, bada boom. We've just changed this to, I think it's 23. Yeah, change that to 23. Now what I am going to do is I'm going to put this to 5 just to show you guys. I don't even, well, I think it's going to, so if I try to build it, it's going to build. Okay, the compiler doesn't check. Again, C++, it's a smart language, but it's not that smart. Now, if I try to run it, I guess it didn't quit. If you're using this in like a Linux environment, I think it would. At least it should, just because that's what I've been using for classes, and I've been getting those kind of errors left and right where you go outside your bounds. But yeah, so this. What you've done is you've gone off and changed memory that doesn't belong to you. But so sub 4, that's the biggest one you should do. A nice way to make sure that you don't go outside of your range is what you can do is you can just create a constant. So let's make a const int scores size. And now, like, every time you go to access a variable, what you can do is you can just say score size -1, and then that'll make sure that you never, like, if you want to get that last element, make sure that you don't actually go outside your bounds. Okay. So yeah, that's the basics of an array. Does that make sense to everyone? Anyone have any questions? Maybe I should be checking the Zoom chat. I don't think anyone's chatted anything. Oh, there is 2 in the chat. Yep, just leave. Okay. Can I put it over there? No. But yeah, nobody had any questions about that? It's all good? Yep. So just like any data type, you can make an int of any data type you want, because they're treated the same as a data type. It just, you're making a bunch of them, and it's a nice way to store things like that. So this right here, what we've done is we've created an empty array. What you can also do is you can come in here and you can initialize the values. So just like we would normally say like equals, like we had just an int, we could say equals 5. If you want to initialize the array, you use your curly brackets again. And then, so the first value, let's just say is 1. And then you just separate every value you want to put in here with a comma. So 1, 5, 7, 9, and 2. So now what we've done is we've initialized this array. So if I come in here and I see out the scores sub, make sure it's attached, scores sub 0, accessing that first array position. What are you mad about? We should probably give this to value, shouldn't we? So. Well, I'll explain that later why I did that, but actually run it. Equals, shoot, equals 5. I was thinking pound define there for you guys in the 150. So yeah, we've initialized this value to 1. Now, if I were to come in here and not actually put all the values, let's just say I only put values for the first 2. What it does is it then just basically initializes the rest of the values to 0. So if I come in here, access the element in the third position, just get to 0 because I only initialized those first 2. So yeah, that's pretty simple stuff. The reason you notice me just come in here and change this to the score size, just literally force of habit, because when you're making arrays, it's really good. It's a really good idea to make a constant that you can just go and change. Because if I make this a 5, and I want to like do something to the entire array, if I have to change the number of elements in the array, I have to go and change it everywhere in the program. So what it's a good idea to do is make that const, and then what you do is you just change it up here. So I can make this 7 now. And I can, it just basically increased the number of elements in the array. Another thing to notice about or remember about arrays is that once you set the size, you can't change it. Because when your compiler, or not a compiler, but when your computer goes to run your program, and it makes a data spot, it basically all the memory that's being allocated in your computer, it just goes right down the line and makes it. So basically once you've made it, there is something else like right at the end of it. So like when I was over here, I told you shouldn't access the 5th element. That's because either your program is using this for something else or some other program is using it. So this is some garbage from like Chrome or something. So Chrome is using that. So yeah, that's not yours, like I said before, and trying to remember where I was going with this, but yeah. So yeah, that's why you can't change the size of your array once you've declared it. There is things out there that are basically the same as an array, but it'll let you change the size. But arrays are built in; they're super nice for things that for most of anything you're going to do. And you guys will use them for those of you in 150. I don't know if you've gotten to them yet. But all right, so I've got like 10 minutes, and that's given me enough time to go over the last basic loop. So we went over well, I guess I only went over the while loop, didn't I? But there's another type of loop, and it really goes hand in hand with arrays, and that is the for loop. So the while loop, it literally just executed as long as something was true. And you can basically create a for loop with a while loop. It's just not it's not as nice. What a for loop is it's a loop that's going to execute a certain number of times. So like if you were taking like the drag and drop block code programming, what you'd probably find is just a loop, and it just says like, do it 5 times. That's what a for loop is. I'm going to leave all of this, and I'm just going to come in here, and I'm going to show you the syntax for a for loop. There's a little more going on here, but it's really simple to understand, and there's 3 parts to the for loop. There's, of course, the keyword for. You're going to use your parentheses again. Oop, not a semicolon. That's important. And then there's 3 sections. The first one you do is it actually allows you to create a variable to do the counting. And then that way it only does the counting and it only belongs to the for loop. So you're always just going to make an int. It's standard just to use I equals 0. Okay, and then you use a semicolon. And now the next element of this is when you want to stop. And what you're going to do is you're just going to compare I to something. So while I, so while I is less than 10, so it's gonna count basically I until I is less than 10. And then the next one is what you actually want to do to your variable. And it's just going to execute after every time your loop runs. And we're just going to say I equals I plus 1. So it's just going to add I every single time, and then you use your true curly braces. And yeah, so now anything that goes inside of here will execute for as many times. So we can just like see out, let's just see out I. We can access it. Why not print it? And you'll see actually there's still this one here. So it printed another 0, but counted right on up to 9. And now the reason that this goes so nicely with arrays is if you have an array and you want to access every variable. So let's say it's a new game and I want to change all the scores back to 0. What I can do is I can just say scores scores sub I equals 0. And so now on the first iteration, I is 0. So it's going to change the first element to 0. Again, second, I is 2. You get where I'm going with this. It just goes through the entire array. And again, another reason to use this constant is you can just say, well, I is less than score size. And it'll go through and it'll change all the elements. Now, you can obviously use a for loop for anything you want. There's a lot of applications for it. But this is the syntax for it. It's pretty simple. And one other thing I want to point out real quick is that this, nobody does it like this. There's a very nice operation you guys, it's not really an operation, yeah, it's an operation. But there's something built in that's called an increment. So what you can do is you can just simply say I plus plus. And that just increments it up one time, every time increments it, yeah, up. You can also do I minus minus, decrement it, put down 1. But that's a really nice shorthand. So yeah, for loops. There's not really a case really that I can think of in the robotics where we're probably going to use a for loop, but I don't know. We'll see what you guys come up with at points sometimes. So let's see here. And of course, just like any other loop or whatever, you can put for loops inside of for loops. And also, another good thing to remember that this int can't be accessed outside of the for loop. It's created here. And once the for loop is done, this int actually just gets destroyed. So, does anybody have any questions about that? Does anybody have any questions about anything we talked about? I think that was basically the end of, I actually did more than I thought I would have time for. So yeah, this probably won't go the full 2 hours. I'm just trying to think if there's anything else about classes that I missed. I don't think so. Actually, classes, one thing I should mention is you don't even need to split it up into 2 files. So if you ever see someone just make speaker.cpp, you can just come in here, declare it, all that jazz. You'll see that. Sometimes you'll see them come in here, they'll make their class and they'll like do this down below it. and then they'll just have like no H file. You'll see that sometimes. In fact, if you look at the Lunabotics code from last year, that's how they did it. You just have your CPP file, class, and then you declare your things down there. Leif, I don't know where the recordings are going to be. That's the same question. And if she comes back in, then I'll ask her. So yeah, honestly, the thing about programming, it's like learning a language. So it's going to be a lot at first. It's just a lot to remember. You'll get used to it. And I still look up things regularly, like Google, how does this work? Because there's just honestly so much out there that you could possibly know. Yeah. Sam, where are the recordings going to be for this?
I'm going to put them on YouTube.
Oh, okay. Yep. YouTube, she said. So yeah, there's the YouTube. SDSU Robotics has a YouTube channel, and then that's where they're going to be. So.
Once they're on there, I will put them on. Once those guys are on YouTube, I'll send out an email. I'll put it in my email.
She's going to send out an email when she gets them up on YouTube. So if you guys want to go back and watch them, you can. But yeah. Otherwise, I think that's all that I had planned for this. I think we have our pictures pretty soon, don't we, Sam?
Yep.
Okay. So I think that's it for today.